seasons. To the inhabitants of Earth's temperate mid-latitudes, they are just a part of life. Familiar and, for the most part, constant. The new growth and sweet fragrances of spring. The warmth and long daylight hours of summer. The vibrant colors of fall. And the crisp chill of snowfall in winter. But seasons are not the same everywhere on our planet. In many tropical areas, there are only two seasons, rainy and dry. In the polar regions, it seems to be winter all year round. And close to the oceans, the seasons take on different characteristics. Why? As with almost everything else on Earth, the seasons are controlled by the sun. Every second, the sun pours vast amounts of energy into space at a rate that is virtually constant, and it has done so for millions of years. When the sun appears directly overhead, its energy provides the equivalent of a 100-watt light bulb plus one 25-watt light bulb over each square foot of ground. But because of Earth's spherical shape, the sun's energy is not distributed equally over the surface. If we were to take a giant strip of photographic paper and lay it on Earth's surface from pole to pole, we would find that while the incoming solar radiation, called insolation, measures full intensity at the equator, at the poles it drops literally to zero. This explains why the poles are so cold and covered with ice, but it doesn't explain the change of seasons. If Earth's equator were aligned with its orbit around the sun would always appear directly overhead at noon on the equator. But Earth's equator isn't aligned with its orbit. Instead, it is tilted nearly 23.5 degrees. Because it spins on its axis, the Earth is like a giant gyroscope, its poles always pointing the same direction. On one side of its orbit, the North Pole tilts 23.5 degrees away from the sun, and the South Pole tilts the same angle toward the sun. This happens on or about December 21st every year and is called the winter solstice. But on the other side of its orbit, the North Pole tilts 23.5 degrees toward the sun, and the South Pole tilts the same angle away from the sun. This happens on or about June 21st every year and is called the summer solstice. If we use another giant strip of photographic paper, we see something different than before. When the sun was aligned over the equator, the insolation was highest at the equator. But in June, insolation is highest 23.5 degrees north of the equator. This is called the Tropic of Cancer, or the Northern Tropic. And in December, the sun appears overhead at 23.5 degrees south of the equator. This is called the Tropic of Capricorn, or the Southern Tropic. It's almost like moving Earth's equator, and the resulting increase in temperature and the pole of the Earth's other hemisphere, with the resulting decrease in temperature to the north at the winter solstice. It is this annual change of insolation that causes the seasons. There are also a few minor influences on Earth's seasons. The first of these is atmospheric circulation. Caused by differential solar heating of Earth's atmosphere combined with our planet's rotation, these vast masses of air stir the temperatures, causing warmer tropical air to move toward the pole and cold polar air to be pulled toward the equator. Perhaps the most dramatic manifestation of this is seen in hurricanes, also called cyclones, which occur as part of the annual cycle of the seasons. The second of these minor influences on the seasons is oceanic currents. Similar to atmospheric circulation, these currents carry warm water from the tropics toward the poles, exchanging heat and humidity with the atmosphere and moderating coastal temperatures. Another of these minor effects is the tiny variation in Earth's orbit around the sun. This variation is just over 3% of the distance from Earth to Sun and brings our planet closest to the sun shortly after the winter solstice. This variation causes winters in the northern hemisphere to be fractionally warmer than in the southern, and summers in the northern hemisphere to be fractionally cooler than in the southern. Finally, there is one more change which also takes place as a result of the tilt of Earth's axis. Earth rotates on its axis every 24 hours. In the spring and fall, the sun will momentarily align with Earth's equator, making the length of day and the length of night 12 hours each. This happens on or about March 20th and is called the vernal equinox, and 6 months later, on or about September 20th, and is called the autumnal equinox. But as our planet approaches solstice, daylight hours in one hemisphere increase, with night hours decreasing equally. In fact, above the polar circle, daylight consumes the entire 24 hours, leaving no time for night. In some parts of the world, this is called the land of the midnight sun. In the other hemisphere, daylight hours decrease, with night hours increasing equally. Above the polar circle in that hemisphere, the Earth descends to 24 hours of night with no daylight at all. As Earth continues its orbit approaching the other solstice, daylight and night hours change, favoring the other hemisphere. Please join us again next time for more amazing facts and images of our planet from Starlight Express.